Coming up next, Mercy. Even though it might seem harmless, this little white box is capable of traversing all kind of terrain thanks to its 4 Daguwal thumper wheels, revolved by 4 12DC motors. It is fast, it is agile, and it is strong. It can even carry your laptop.
Essentially, Mercy is a mobile robot that dreams of becoming a personal assistant for elderly people. To do so, it will have to become fully automated and new mechanical parts need to be added to its current design. However, as of yet, it is perfectly controllable via radio frequency controller.
She was designed thinking of elderly people because we consider that taking care of the ones who took care of us when we were kids is about the noblest thing we can do with our techie knowledge. Furthermore, it is important to recognize that as age goes by, a human's physical and mental capabilities tend to decrease, for which is imperative to safeguard elders from daily risks.
Mercy's structure is simple. Its outside shell is a rectangular wooden box that helps keep and protect its circuits. On its top, the little black device that can be seen is a LiDAR. Mercy hasn't learned to use it yet, but it is intended to serve as her eyes, for its laser will help her detect obstacles, measure distances, and create maps.
The rear part has 2 switches and a 3.15 ampere fuse to protect the robot from discharges. The yellow switch is the main on-off button, while the red one only affects the motors. Nonetheless, both switches must be on for Mercy to be able to move around. Notice that a small LED below each switch will shine bright when it's on.
Mercy's face currently has nothing but a hole. During this first stage, this serves no purpose, but later on, it will become a water and pills dispenser. Finally, Mercy's bottom has nothing but her 4 wheels and DC motors.
Right now, Mercy inside are composed only by its circuitry, but soon enough, a water tank, a rotating pie-shaped pill selector, and a dispensing mechanism will join the show.
In a nutshell, Mercy's circuit is made up of an Arduino, a couple of batteries, one for the motors and one for the Arduino, and 2 motor drivers to give speed and direction to each pair of motors. Currently, the Arduino board is Mercy's brain. It receives the signal from the RF controller and converts them into a PWM and digital signals to control the drivers. A Raspberry Pi 3 can be observed attached to one of the sides. This will allow Mercy to connect to the local network and to get information from a PC and the LiDAR, which will help her navigate.
Mercy's controllability is simple. There are 4 main commands that even a kid can memorize to be able to take Mercy anywhere. To move to the front and back, simply move the controller's left stick in the desired direction. Keep in mind that this stick also controls speed, for which the more the stick is pushed in either direction, the faster Mercy will go.
To make Mercy turn, give her some front speed with the left stick while moving the right stick either to the left or to the right. Make sure to push them all the way and remain pressing them until you want Mercy to stop turning.
Heroes never die.
Mercy now has additional functions that will allow it in the future to be a perfect assistance robot. At the top, a small compartment has been added where you can open and deposit on the 3D printed reel the necessary pills for the week. Also, below it, a box has been added for the front opening that existed, so it is now completely closed and allows for 2 different entries to either give pills or even water.
Mercy is meant to dispense pills for elderly people that are unable to move. In this part of the project, we want to keep the design simple and beautiful for our robot. The fan and the dispenser were 3D printed in PLA plastic and designed in SolidWorks. We made several attempts for the fan piece until we obtained the final design. Also, we investigated how to control the servo to drive the pill dispenser, and we found out that it can only rotate 300 degrees. With all this work done, we are getting close to the final results. We are missing important parts like the water tank inside the robot and the voice commands, but in the final project, Mercy will look complete.
Mercy is now able to map her surroundings. To accomplish this, 3 different components were used: the LiDAR, a Hector's lamp, and a static transform. Hector's lamp generates a 2D map based on the readings from the LiDAR. This technique is useful yet simple. as it does not require telemetry to operate. Instead, a reference frame is placed where the map starts to generate, and translation is calculated using the inputs from the LiDAR. The static transform is quite important too, as it allows Hector to perform accurate calculations taking into account the offset of the position of the LiDAR with respect to the base of the robot.
The teleop node is the link between the user and the Arduino. Developing this application as a second way to control Mercy was necessary for two main reasons. Firstly, even though the node currently works with keyboard inputs, it will later be adapted to work with a routing and control node, which will calculate and send linear and angular speeds, thus making Mercy completely autonomous. Secondly, it works great as a debugging tool, since we can control Mercy with precision through it without being physically close to her.
Mercy also now has a water pump on the side. One of Mercy's purpose is to provide water so that the user can take the pills immediately after he or she has received them. This pump will transport the water from a container into the dispensing area. As a physical additament, Mercy now has two pads on the back, which have the purpose of conducting energy to its battery. This might allow the implementation of a charging station in the future, since charging Mercy doesn't require for it to be opened.
Mercy is now an autonomous robot capable of steering, accelerating, deaccelerating, stopping, and changing its path without human intervention. To achieve this result, Mercy reached several milestones, the most significant being semi-autonomous navigation. While in the semi-autonomous navigation phase, Mercy was able to avoid obstacles and to analyze her environment with a given teleoperated command. However, she was not able to locate herself within a map, which was the main difference with the autonomous navigation.
The ROS package that allowed us to achieve both phases was called Nav2D. This package contains several launch files with examples regarding autonomous navigation. Our task was to take these examples and to adapt them to a robot. For the semi-autonomous phase, Nav2D analyzed data obtained from the RP LiDAR to give feedback about the robot's path in order to change it, avoiding any object in front of it.
On the other hand, in the autonomous phase, Nav2D situates Mercy in a two-dimensional map where she can locate herself. We were allowed to send Mercy to a specific location in the map, and Mercy would reach the location following a route generated through Nav2D, avoiding obstacles and objects along the way. Nonetheless, we encountered several setbacks while implementing this part of the Nav2D package. Instead, we used Hector Slam as a supporting tool.
To achieve a better result alongside Nav2D, we implemented a differential controller for the wheel's speed. We realized that not all of the motors had the same movement behavior because of the uneven load of the robot. We performed several tests and decided to improve Mercy movement using a PID controller, which was carried out through an Arduino library.
Finally, the last physical modifications made to Mercy were related to the final application. Different support and protection pieces were 3D printed. Mercy already had an external water pump to provide water to the user, but a protector was added to avoid damaging it. All the accommodations to place an internal water bottle were made, as well as support for placing cups and for the pills to fall in front of Mercy. The servo motor that controls the pill dispenser was also placed and implemented.
I am quite happy with the results we obtained. Although the journey was quite exhausting and filled with obstacles and challenges, in the end I can finally feel relieved that all our individual and group efforts paid off quite handsomely. By building and programming Mercy, I did not only learn how to use ROS and about the different open source nodes built to facilitate projects like this, but I also reviewed and relearned lots of concepts I learned in previous courses. This final project served as a perfect summary of my major, as no two challenges were the same, nor required the same knowledge or skills to be overcome.
Now that this project is finally over, I'm able to look back to the past and see all the effort and hard work that was put in this robot. Even though the road was bumpy and had lots of highs and lows, I am happy to see that in the end it finally led to success. Building Mercy was indeed a challenge, but thanks to all the planning and teamwork, we were able to sort most of the obstacles in our way. This project tested our knowledge, skills, patience, teamwork, and perseverance, and helped me to identify my strong and weak points, and I consider that something invaluable.
Mercy is finally over. Through the semester, we made it possible to integrate knowledge from both hardware and software from our whole career into a palpable and innovative project that completely relied in teamwork and clear objectives. These results are pretty satisfactory with what we achieved in a semester, and we hope that the knowledge and the skills learned from this project will further help us in our professional lives.
I am content with the result of this project. Throughout the semester, the team worked hard to achieve the final result. I believe we learned a lot about Rust, and we were able to apply a lot of concepts from different past courses. Nav2D is a very complete package that came with a lot of examples, allowing us to experiment with them, reaching even further than we imagined. I am sure that the different skills obtained through this course make us better professionals. Overall, I think we created a great project that can serve as a base for future students taking the course.
Mercy has taught me a lot of things, like how to work as a team, deal with mechanical issues, and how to fix the software quickly. I think that this project joins all the content of many classes that we took during the major. And these things paid off, because we are creating a product that could help elderly people to improve their lives. Despite of the problems we faced, I'm glad with the results. Mercy was born since nothing. Now we have a final product that we can show to the world.